Hello, the purpose of this video is to clarify the most recent assignment that I gave, to make sure that everybody understands what we're doing and why we're doing it. So first of all, the primary purpose of this assignment is to get us to understand how we can look at a function, or how we can discover or uncover functions in everyday life. Now, I'm going to grant you that shooting a cannon is not part of our everyday life, but this is a simplification of physics, of projectile physics. And so what I'm recognizing here is I can change the angle of the cannon, and that's going to have an effect on how far horizontally the cannonball will fly. If I change the angle of the cannon, it also has an effect on the maximum height achieved by the object. But I can also change the initial speed to whatever I want, and that's also going to have an effect on the vertical height and the horizontal distance. And so I can move the cannon itself around, I can move the target around, I can change the angles however I want, and the speed. Looks up here like there's time. That shows me how long the object was in the air. It also tells me where the object is at any moment in time. And range here is essentially giving us our horizontal distance. So that's kind of nice. So anyway, these are all sort of very complicated and interesting variables that we're looking at, and what I want to show you all that we can do is we can take all of these relationships and describe them using the conventions of writing and mathematics. Essentially, we're going to uncover functions and then explore or study those functions. So what you need to do first is you need to go on to the document Cannon Variables List. Now, we edited this document as a group, or as groups in class. And what I wanted to get everybody to understand is make sure you go back on here, because what I did is I went through and I did some edits to make sure that the list is appropriate, that the variables are the kind of variables we can measure in this process, and that the functions are actually functions, legitimate functions in the process as well. So what you need to do, you're going to do this twice. I'm going to show you one example. We're going to do this twice, though. You're going to go to this list and you're going to find a function relationship that looks interesting to you. So what I found here was the height is a function of the initial launch speed. That is something that I want to explore. So I can change the speed of the launch, and that's going to affect the maximum height of this particular cannonball. So I'm going to copy this function relationship, and then I'm going to open up my file that says Cannon function relationships. This you'll find in your shared drive. And what I'm going to do then is I'm going to replace the blank as a function of blank. I'm going to replace that with the maximum height or vertical distance of the cannonball as a function of the initial speed. Once I have that established, I have to make sure that I label my table correctly. You see right in here. So I'm going to label my initial speed in meters per second as the independent variable, and then my vertical height in meters, that's going to replace the phrase dependent variable. Then I have to collect data, so I go back to the simulation, I change my initial speed to whatever I want to start with. I'm going to go by 5s here, and I'm going to launch the cannonball. As you can see right here, the cannonball did not go very far. It didn't even get out of the cannon, in fact. But I can still measure what happened to it, so I'm going to line up the tape measure on the crosshairs, and then I'm going to grab the other crosshair and pull it up to the maximum height attained by the cannonball. And I could read this right off there. It's about 1.35 would be that height. So I'll go back to my data table, and I enter the data, or it's 1.34. So at the initial speed of 5, I went 1.34 meters in the air. That's about 3 or 4 feet in the air from a 5 meter per second blast. So go back to the simulation, erase what I have, change my initial speed now to 10 meters per second, and hit fire. So as you can see, the cannonball is going up much higher this time, and I measure it at around 5.4 meters. So I go back over here and I add the data, 10 meters per second, 5.13. Now again, this I measured earlier, and I got a different measurement, so I was being a little careless this time. But nonetheless, I put that data in, go back, erase, change my independent variable, and measure the impact of the dependent variables. I measure it up, go back to the table, record the data, and so on. So we can basically just complete the table until we have enough data to be interesting. We don't always have to go all the way to the bottom of the table, but we should at least have 6 or 7 data points to work with. So Your job then is to collect the data, and what I did here is completed that process, and now I have a complete data table based on my information. The other thing that I want to do here is I just want to add a little information at the top of the document to state that the angle of launch was fixed at 90 degrees. The height of the cannon was ground level. I'm leaving these notes to myself because if I want to replicate this experiment and check to see if my data were collected correctly, I want to make sure I know what stuff was fixed before I continue on with all my data collection. So what I've done here is I've collected all of the data, and I get a sense that every time I increase the initial speed is going to have an effect on increasing the maximum height attained by the cannonball. But this is just a bunch of numbers, and it's hard to really see what's happening here. So what I need to do is go to a piece of paper and start constructing a graph. So you can see I have my table right here, and I'm constructing a graph using a ruler, and I have to get all the labels in before I start actually plotting my points. So what I did is I used a ruler to make the x and y axis. I stated in here the title, which is the function relationship that I am studying. And then I had to choose an appropriate scale. Noticing that we're going up to 35 meters per second, I think it would be unwise to make your scale count by ones on the x-axis. If you did that, you would have a whole mess of tick marks and your graph would become chaotic. I chose to count by fives. So every centimeter I went 5, or maybe this is, 2 centimeters. Every 2 centimeters I went 5 meters per second further away, and I gave myself a little breathing room on the right-hand side. My table went up to 35 meters per second. My graph goes a little bit further so I could extend the graph if I had to. Vertical height starts off really small, 1 and 5 meters, but by the time we get to 35 meters per second, the vertical height exceeds 60 meters. So when I make my my y-axis, I need to scale it in such a way that I will be able to see all the way up past 60 meters. So I counted by tens and went up to 70 meters, and this should be enough for me to be able to, to collect my data. Now what you can see here, I've actually plotted each of the points from my data table, and once all of those data were plotted, and by the way, I should tell you, I used a ruler to go up and to find the appropriate height. I used a ruler for every one of these points because if my points are shifted to the left or the right or up or down from where they should be, it's going to skew the data and you're going to get a graph that's going to look all chunky instead of smooth and continuous. So once I had all of the data plotted, then I took and drew a curve that goes through all of these points. You'll notice I didn't go line, line, line. I didn't connect all these points with a line. What I did was I interpolated by basically assuming that the rest of the data, if I went in between 5 and 10 meters per second, would probably fall with a maximum height somewhere around here. So we're going to figure out what this graph is good for and what we can do with the graph, but for today, this is the primary skill. We collect data. We collect data using the measurement tools on the simulation. We do that after we've selected the function relationship that we want to study. After we've collected the data and completed the table, we will then go and complete a graph. And that graph should clearly indicate all of the information that you collected on the data table. Take this picture and take a photograph of it, put it into the same document where you collected your data, which in this case would be right here. So I would actually take this graph and I would copy it and paste it onto the end of this document, right underneath the table. So right here would be a picture of my graph. Okay, then I go and do the entire experiment over again. This time I pick a different function relationship. I use number 2. I put in the function relationship. I label my variables. I collect the data. I make a graph, and I put the graph down here. So that should pretty much be it in a nutshell. Thank you for watching. I hope this was helpful.